test the effectiveness of a drug used for treating insomnia in older subjects. After the treatment with the drug, 21 subjects had a mean wake time of this and a standard deviation of that. Assume that the 21 sample values appear to be from a normally distributed population and construct a 98% confidence interval estimate of the standard deviation of the wake times for a population with the drug treatments. Does the result indicate whether the treatment is effective? All right. So this is a clinical trial. We're doing some drug work here. We're going to put this right over here and go to town. It looks even bigger up there. So let's see what we know. We have how many subjects? 21 subjects. So that means our degree of freedom is 20. This is on our table. I think we can work with this. It's on our chi-square table. All right, we know the standard deviation of the sample is 42.9 minutes. And it seems to be normally distributed. And this is a clinical trial. Now, I don't see anything about it being random, but I'm assuming that the clinical trial must have been random with blinds and double blinds and all that stuff. So I'm assuming that all of the requirements are met. It does say that it's normally distributed. We're trying to do a 98% confidence interval estimate of the standard deviation for this population. So that means that we're using the chi-square distribution. So of course our little chi-squared situation is looking real specific. We've got 0.1 on this side, and we've got 0.1 on this side, and 0.98 in the middle. And our chi-square to the right value here is going to deal with an area of 0.01. Our chi-squared to the left area here is going to be an area of 0.99. So that's what we're looking at on our table. Now, what does it look like on our table? So pull out your table and see what your chi-squared value is going to look like. I got to find mine deep down in a book somewhere. So since my degrees of freedom were, what was it? It was 20. I come down to 20. And for my right value, my chi-squared to the right, ooh, forgive me for this chi. Ooh, that looks pitiful. You know my heart. All right, so the chi-squared to the right is underneath the 0.001 value on that 20 row. If I'm not mistaken, that's 37.566. But look at your table, and if it's a different number, blame it on the head and not the heart. I think I'm on the right row. And then when I look at the left value, the chi-squared to the left, where the area is 0.99, is going to be 0.826, or 8.260. Sorry, that point should be in between the 8 and the 2. Watch me fix it. What won't he do it? There it is. All right, now we use our formula. Remember, it's n minus 1 for our degrees of freedom times our standard deviation that we have squared divided by each of our chi-squared values. So we start out with the chi-squared to the right, the bigger number, and that's going to be less than the variance, which is less than the same formula on the top, n minus 1 times the sample standard deviation squared, or the sample variance squared, over the chi-squared to the left value. Now on the bottom, even though that looks like it's being squared, that's just the name of this. It's called the chi-squared. And we plug it in, plug it in. So let's get our handy dandy calculator out and get to plugging it in. Now notice that I didn't go over here to stat crunch because the only chi-squared calculations we can do deal with hypothesis testing there. So, oh well. So let's come over here and hope my calculator pops up on the screen. Keep your fingers crossed that it'll pop up. If it doesn't, well, we do the best that we can. Let me press on that again. There it is. Good for us. All right, your calculator is a little bit fancier than mine, so I'm pretty sure that you can do this quite well. Since we have 21 data points, we're going to type in 20 times that 42.9 squared, so 20 times the 42.9, because that's what they said the standard deviation was, a big standard deviation, squared, divided by our chi-squared value for the right, which is 37.5. I hope that's an 8. My Lord, I don't know what my handwriting looks like. Let me go back to that table and make sure. We're on row 20 under 0.1 and that is 0.66. I'm sorry, that should be 2 sixes. I was about to put an 8 in there, so make it 6 instead. Look at your own table. Trust in yourself. All right, so I get 979.82, and I'm going to have second square root, second answer, because I want to do the square root of that answer. Boy, that's a big number, and we get 31.3. So 31.3 less than standard deviation of the population. And then we come over to this side and we do this again. So we have 20 times 42.9 squared. But this time we're going to be divided by 8.260. 8.260. And that gives us a large number, 4,456. Second square root, second answer. So we can get that answer in there. If you're more comfortable typing it in, go right ahead. And then we get 66.75. 66.75, 66.8. Let me come over here and see what they want me to do. They want me to go to 2 decimal places. Of course they do. So this will be 31.30, and this will be 66.75. Fingers crossed that this is right. Come on, let's get it right tonight. All right. 31.30, 66.75. There we go. Hope that helps.